Hi there. Welcome to my talk about protecting your app from malicious code in third-party libraries. First, a few words about myself. My name is Marina and I've been working as an iOS developer for over a decade. I've worked in larger companies like Citrix and Storytel, and these days I went independent and I'm consulting for larger companies, advising for startups, mentoring and curating a newsletter called iOS Code Review Newsletter. You can follow me on Twitter at hybridcat with 3 T's, or the newsletter at iOS Code Review with underscores, and you can subscribe at ioscodereview.com. So this talk is actually recorded, so you're welcome to post questions on the chat, and I will reply while the talk is ongoing. So let me walk you through what you learn from this talk. So we'll look at how malicious code can be injected in your app through third-party libraries. Then I'll give a few tips about vetting open source libraries before using them. And we'll look at some techniques on minimizing the future risk of new updates of libraries, including malicious code. And before we dive in, I want to talk a little bit about why it is important even to talk about this stuff. So third-party libraries are a staple for software development these days, and usually we trust popular open source repositories or big vendors, but sometimes we have to use less popular libraries with less contributions or from less known authors. And there have been big stories about vulnerabilities in third-party code. Usually that's talked about for web SDKs and web libraries. But app codebases are as vulnerable to malicious intent as web ones. So in this talk, we're gonna, of course, focus on the app libraries. So when we include third-party code, we have a few options. We can use open source libraries, usually from GitHub. Then it gets built from source as a dynamic or a static library and linked against in our app. We can use precompiled binary libraries that are usually provided by bigger vendors that don't want to share their code open source. And then also when we include any library, it can have other dependencies that it brings along that we're not necessarily directly aware of because we're not including them ourselves. So when we include a library in our code, what do they get access to? And libraries and dynamic frameworks or static frameworks, they essentially execute the code in the same runtime space as our app code, so they have access to everything that our own app code has access to, such as the UI hierarchy, accessing files on disk, accessing keychain, user defaults, push notifications, or anything really. And how do they do that? They can, in the worst case, do Swizzlings when they can hook up to any method in the that exists in our app. They can subscribe to NS notifications sent by the system. They can hook up to observers like StoreKit and grab such events. Let's look at these in a bit more detail. So with NS notifications, or the notification center, our apps are pretty much riddled with notifications, and usually we're not observing most of them, but there's a lot of notifications one can hook up to, such as app lifecycle events like did finish launching, getting the parameters that the app is launching with, like the notification that the app was launched from. They can also hook up to text editing notifications that come from from text fields, and playback notifications that come from AV Player and so on. Then they can hook up to StoreKit by observing payment queue, and that goes for both StoreKit 1 and StoreKit 2, where we get a bit nicer API with Swift concurrency. Then you can register a custom URL protocol that gets to intercept all of the URL requests made even from the shared URL session. Then they can also alter view hierarchy, like for example, add a UI window that is covering the whole app UI and catch touches and button presses and gestures off of that. Now let's talk about Swizzling. Swizzling is a tool that lets you exchange implementations for Objective-C classes, or rather classes that are exposed to Objective-C. They can be written in Swift as well. So what it means is that you can exchange implementations with just a few lines of code, like shown here on the slide. And in this example is hooking up to the view will appear method on every single view controller in your app, and then you could execute whatever code. In this case, it's just printing, but you can track, log these events, or basically do whatever good or bad with this approach. And gladly, all the libraries we know of, or most that we know of, are leveraging these tools for the good. So there are different examples, like for example, there's a library called Flex that offers live debugging tools where you can include it in your app. You should do it only in debug builds, of course, and then you can inspect the view hierarchy, the colors and the structure, and change things. That's really useful. Then there are SDKs, usually from big vendors, that do automated tracking, like automated tracking of in-app purchases or opening different screens and so on. Then there are, for example, customer support SDKs that put an always on top view, such as, for example, in Intercom, that the user can press to then pull up the support window with a chat, and you don't usually need to do anything like custom code there. It's all handled by the SDK. And then, of course, the all well-known crash reporting SDKs, they hook up to the crash handler automatically. So that is also nice, and that as developers, we don't need to write additional code to get that functionality. But with all these tools, you can do also bad things theoretically, like through accessing the view hierarchy, through notifications and accessing the UI views and Swizzling. Theoretically, you can have code in a library that accesses all the text fields, labels, and even secret ones for passwords. They can inspect and access and log all the HTTP traffic, including all the requests and responses. They can access private user data that you store locally, such as the core data, database, user defaults, keychain, and so on. And they can also track user actions from button presses, swipes, and whatnot, whatever the user does in the app. So this sounds a bit scary and a bit depressing, but there's a lot actually we can do as developers before including a given library to prevent this and catch these things before they affect our users and our businesses. So before using a library, we can vet it and see if this is safe to include in our apps. And there's a few things we can look at, such as how trustworthy the library authors are, what is actually the code of this library, like what is it doing, and then also inspect the runtime to see what the SDK does in our app. So to assess trustworthiness, we can look at things such as GitHub stars, which usually indicate how many people are using this app. Then we can have a look at issues on GitHub, both open and closed, which is also an indication of the general quality of a library, how many open issues there are, and if there's basically any support or fixes coming in. But also we can see issues, noticing some things that, oh, this library is doing something it shouldn't be doing. So that we can see in the issues. Then another thing to look at is the number of releases. Is this library being released and fixed regularly? And then look at any notable, if there are any notable contributors, like big names that you know from the community, that then you can think that if they have contributed to this library, then it's probably something you can trust. And then another thing to look at, which is I think last but not least, is to look at the pull request review process and what is the process for this library for including new changes coming in from the community. Because usually, at least in my understanding, the biggest vulnerabilities come not from the fact that the author was trying to sneak in something into the SDK, but that some malicious contributor is putting in a pull request, like a big pull request it could be, and sneaking in a tiny change that should kind of be hidden among all the other changes in the pull request. So that's when the pull request review comes in, where we would expect to see from the authors or from the contributors, from the maintainers rather, of the library, for them to actually go through the changes that are about to be merged, review them, and make sure that there's nothing in there. So if you see huge PRs in the history of the library, that the huge PRs have been merged without any comments from the authors, then that's probably not a good sign. But that's only one thing we can do. We can also actually inspect the code, and we should inspect the code of the library. So then there we can look at those things that I've mentioned earlier that could be an indication of the library doing something it shouldn't do. So look at if there's any swizzling in the code, and you could do that by searching on GitHub within the scope of the repository by these keywords, or you can check out the code and go through that locally. Then you can look at strange or out of the ordinary HTTP calls. So if the library is not doing anything, or is not supposed to be doing anything related to networking, but then you find any mentions of networking code, such as usage of URL session, URL protocol, or even just strings, such as HTTPS or .com that you can search for, then that can be an indication that it's doing something that it shouldn't do, and then you should look at these at this code and see what it is actually trying to do with that code. Why does it need to make networking calls? Then you can look at, in the same fashion, for UI code in the SDKs that are not supposed to be doing anything UI related. Why are they accessing the view hierarchy? You can look for import of UI kit or UI view controller and so on. Then in terms of privacy, we also want to see if the library is using the advertisement identifier and whatever else basically we find during the inspection of the code. Anything out of the ordinary we should pay extra attention to and ask ourselves, is it matching the use case of the library? Now, it's not always possible to fully inspect the code of a library, either because there's just so much code or because we don't have access to it at all. For example, when the library is precompiled and vendored as a framework. That's where inspecting the runtime comes to the rescue. We can run the app after including the library and inspect the view hierarchy to see if there's, for example, a window added on top and if that's expected. And we can, for other things, exploit symbolic breakpoints. So we can hook up to those set methods that we were looking for in the during the code review phase, and instead look for them in the runtime. So hooking up to exchanging implementations, so Swizzling, exchanging or registering additional URL protocols, and so on. So once we do that, we can be pretty sure that right now the library is not doing anything crazy or secret. But what do we do in the future? Because we include the library and we use it as it is now, but going forward the library will be updated. And how do we control that? And how do we make sure that new vulnerabilities don't come at a later date? So for that we can do a few small things as well. So first of all, after reviewing all the code of the library, fork the repository and pin your dependency to your fork as opposed to the original repo on GitHub. What it helps with is versions being replaced or updated as a future date, because essentially versions are just tags in the repo, and theoretically a tag can move. So today a given tag is pointing to one commit, tomorrow it can be pointing to another commit, and so if you resolve your dependencies again, then a different commit of the library would be used, even though it could look like the same version. And also usually we pin the versions pretty loosely, so an update can come at a later date as a patch, and our library will get updated, our dependency will get updated without us really noticing. In connection to that, it's a good idea to pin to an exact version of a library as opposed to pinning loosely to up to next major, for example, because then we can really be in control of what we're including in our app or when we're updating a dependency. And that only really works in conjunction with forking, because again, a tag or a given version can move. So just because we say we're pinned to that version doesn't necessarily mean that we're going to be on the same commit next time we resolve dependencies. And so every time we want to update a dependency, then we can go through the changes on the parent and pull from that upstream into our fork and go through all of the changes in the code. Usually that would be incremental, so it's less big of a job than originally reviewing the library. So all of these things together can help us really control what we put into our code and what we let external developers and potentially someone with malicious intent do inside our app's runtime space. And unfortunately, these things don't 100% protect you from anything. It's all based on how much effort you can put into reviewing these things and keeping those things in check. So you basically have to choose your paranoia level and in the end just do these things to mitigate risk. So there's always risk. We can only do these certain steps to help us make the risk as small as we can. And yeah, just to round up, what we've looked at today is how to vet your dependencies, understanding attack vectors of what the dependencies can do in your app space, and how to update your new versions carefully. So hopefully that was helpful and you will take those learnings and will not be scared, but rather just be aware, and just being aware is already much better than not being aware of the risks at all. So hopefully you learned something new, and thank you so much, and stay safe. Bye.